about a state of the art or studying the state of the art of data management in microservices. So please, Rodrigo, the floor is yours.
Hi, hello everyone. My name is Rodrigo, and I will present today the paper Data Management in Microservices, State of the Practice, Challenges and Research Directions. This paper was written by me, my advisors Yongluan Zhou, Marcos Salles, Yijian Liu, and Marcos Kalinowski. Let's go first for a brief background. Traditionally, applications have been written using the so-called monolithic architecture. In this traditional way of building applications, subsystems or modules, they are packaged together as a single deployment unit. This deployment unit is deployed over an application server, and the state to this application is deployed separately in a database server machine. All these subsystems, they share the same database state. More and more, we have seen the emergence of the microservice architecture. What are microservice architectures? Basically, in a microservice architecture, each one of these subsystems, they are decomposed into loosely coupled, high cohesive application modules, where each one of these applications modules, they have their own private state, and they're only supposed to communicate with each other via message. For example, RPC or even asynchronous events. Different microservices cannot access or are not supposed to access the private state of other services. So the motivation of this work is centered in understanding more about this emerging architecture in terms of data management. So, okay, state is partitioned, they end up encapsulating their state into independent microservices. But it remains unknown, like what are the database systems technologies these architectures are using? What are the deployment patterns in terms of databases? What are the mechanisms to exchange data between these different microservices? What are the data consistent semantics that are employing this architecture? Most important, what are the pressing data management challenges developers face today in practice? And what are the research directions for our community to embrace? So we put forward a research methodology divided into 5 steps to further access this matter. First, we analyzed more than 200 peer-reviewed papers looking for what are the common data management practices in real-world deployments of microservice architectures. Based on this knowledge gathering, we look for open source repositories of popular microservice repositories. We analyzed more than 20 and we selected 9 for further analysis. Based on the previous step, we validate this management practice, and we also identify further data management pitfalls that are encoded by developers. Next, to further understand all these issues, we designed an online survey. More than 120 researchers and developers who have real-world experience with microservices, they provided their insights and their pains that they have come across while deploying and developing microservice applications. These 3 interrelated explorations allowed us to provide new insights and evidence on the data management practice and also characterize them. Based on all this knowledge acquired, we devised a set of features that are important to address in this type of architectures, thus making the case for the microservice-oriented database systems. So let's jump on to the first part of this presentation. We look for the motivations across developers regarding data management, for the focus of data management. First of all, let's take as example on a web shop. Usually some web shop is usually decomposed into different modules. So let's take example these modules: a catalog, order, payment, user, or analytics service. So let's say, for example, that we have a failure in one of these underlying database, which is a private state of a payment, for example, or even if we have a bug in the order module. That means that because of the independent states, we naturally gain like full tolerance at the application. And also we have higher data availability, because if you have a bug, it doesn't affect the other modules. And also at the same time, if we have some failure, there's also the data that is, because the data is partitioned, all the data that belongs to the other applications, the other microservices are still available for access. Another motivation concerns fine-grained ability. Because these applications, these microservices, they are made to be fine-grained or to compose a fine-grained functionality. That means that naturally we can also adapt better to dynamic workloads and also to resource constraints that appear usually in cloud deployments. Next, again, because of this division, this decomposition, we also naturally gain team dependency. So different teams can order in their own, can work in their own microservice. So we can derive from that like this independent schema evolution of each one of these applications, and also evolution of this data management logic that belongs to each one of these applications. Right. Another important insight that we have gathered is the ability to share data across these microservices. Usually developers are putting forward the idea of event-driven data management. So instead of like pulling data from each microservice, they're going for a more like a synchronous way to propagate these updates. So they can communicate these data item updates to other microservices that are interested in that, and they can also trigger remote computations in neighboring microservices, for example. So what is like a typical deployment? We have seen that usually it was often reported by developers that each one of these microservices, they are usually served by different databases that is better that better fits their workloads and data formats that each one of these microservices works in. These microservices, they usually take advantage of some message broker technology to mediate the interaction between them, thus allowing them to remain loosely coupled. It's usually the case that each one of these applications, they are deploying containerized environments. Let's move on now to some challenges, and I will talk about the challenges in a bit way more higher level here. So feel free to reach out to me during the questions and answers. So although these microservices supposedly are extremely loose coupled and high cohesive, they often sometimes they have some dependence, the data between them. So we look at the e-commerce deployment, for example, the basket, the stock, the order, and the stock. So they usually have to synchronize somehow. We have found that these traditional distributed commit protocols that our community has been building for years, they do not enjoy much popularity in microservice architectures. Developers are going for more asynchronous and non-blocking interactions. But at the same way, they prefer going for this new way of like synchronizing microservices. They also face challenges on implementing concurrency control at the application level and ensuring the correctness of the data. Because data is partitioned, it's also often the case that data should be cross-associated between these microservices. So sometimes we have also witnessed that developers are basically doing querying and data processing at the application level. Because of that, implementing consistent and efficient data processing is also challenging for developers. Naturally, from the first point, because of this data partitioning, it's again, we have found that some microservices, they also have constraints related to their private state. For example, referential constraint. Developers are most of the times enforcing these constraints at the application level. So for example, dealing with dangling records or avoiding that. But it's usually an error-prone process. They also often skew off providing this guarantee. And for last, because of this asynchronous nature of microservice interactions, these asynchronous events, they may impact their private states. So an event basically installs a computation inside each one of these, each microservice. But these events, they are necessarily arrive at the application level, and they are processed at that. What happens is that these interleaving of the events delivers a very challenging environment for developers. who often are not even aware that data anomalies have occurred in the past. Let's move now to the last part of our talk. So the main question is, what features should a future risk database system provide? So in our paper, we have like a full list of all detail, like explanations of each one of this feature. But here I will divide it into 4 major blocks, and I will talk about each one of them now. So basically, a future risk microservice oriented database system should have the ability to understand the events, basically like manage and enforce constraints over events, particularly on the order of the execution of these asynchronous events. In addition, as we have mentioned before, cross-microservice synchronizations are important in this architecture. The challenge here is, at the same time allowing microservices to remain high consistency, is to also allow them to remain loosely coupled. Next, accessing data on distinct microservice states. So cross-microservice recurring is an important requirement for these architectures, but at the same time, a database system should respect the data sovereignty of each one of these private states. And next, the point that I will focus more to the end of this talk is providing proper database abstractions. It's basically, how can we gain knowledge more of about what's going on at the application level? So the meta problem is that application is doing data management. And this sometimes is bad, right, and harmful. So data management logic should not be oblivious to the database. But database systems, they designed to interact with black box applications. They usually provide an API, and the application connects to it and sends statements, SQL statements to it. But in particular to microservice architectures, this is challenging because the databases, they are underlying to the services, they are oblivious of the complex interplay among these microservices. That means that they are oblivious of the data movements that are occurring outside the DBMS. So it's important to provide appropriate abstractions to developers. So database systems play a central role again. How can we do that? We believe that it is important, like, to understand better what is going on with the application and provide a better division of tasks between the application and database. But we can push down data management tasks to the database, it is better. So concluding this talk, microservices significantly deviate from traditional monolithic applications that we have saw, and with that, many challenges are brought. State-of-the-art insufficiently meet the developer's needs today, so they are basically doing data management at the application. Therefore, that leads them to include several pitfalls in the application layer. It's time to rethink how database systems are designed to tackle this new paradigm. Thank you all. I am available for questions and answers in the next 4 minutes.
Great. Thank you, Rodrigo, for the great presentation. Now it's time for the Q&A. So by now, I don't see any question in the portal. So let's wait for a moment. And in the meantime, so yes, I have one question. I mean, in this study that you have done, what was the main pain point from users in the applications? The lack of abstractions in our systems, or do you think that somehow we already have some decent abstractions, but the application developers are some kind of ignoring these abstractions, and we are not reaching them as we should?
Yeah, so what happens is that these cloud deployments, they're still a new thing. So more and more firms are seeing this cloud environment as a opportunity, like, to provide all these benefits that they're seeking. So if we look at the motivations that they're seeking are fine. Like, it makes sense that they seek these motivations. But at the same time, general developers, they are in general, they are not educated, like, to understand all the challenges that we database systems like community have been doing for many years now, because this is such a new environment for building applications. So I think it's a natural process. Like, we have to caught up with their needs, and serve the requirements better, right? So I think this interaction is good to kind of better understand. So the pain point, I mean, maybe I'll be a bit opinionated because this is like towards what I'm doing in my PhD. But yeah, we do believe like appropriate abstractions are the key. So not only exposing like a JDBC API for like sending statements over and back and forth, but more like we need to have a better integration.
And as there is no questions so far, so let me follow up on this. And do you think that this abstraction should be at the DVMS level or DVMS components level, meaning that something similar now JDBC, let's say, so that you can send your queries and so on, or we should have abstractions for what is going to be the log manager, the transactions manager, buffer manager, etc., etc. That goes a bit aligned to what is today this composability of systems, right? Data management that are composable. So what is your take? Yeah.
Oh, it's a great question, and I don't think there's like a final like answer to that. I think different groups are pursuing now like different abstractions. Like there's some groups pursuing like a more like integrating Flink or leveraging Flink. Other groups are leveraging functions as a service frameworks. But I believe that should be a good separation of responsibilities. So to what point the application can go, and to what point the database can open itself to allow more tasks to be executed. So I think these answers can be like better like analyzing in the coming months or in the coming years, like near future.
Okay, great. And yes, there is one question from Jindal. So let me ask quickly, and if you can give a brief answer because we're tight on time. So the question is, what is the main motivation for different microservices to use separate database types? Why is a fault-tolerant distributed database insufficient? Each microservice can manage its own tables, etc.
Yeah, so these questions they often come. I think it's also a matter of the modern ways of how companies they are putting for organizing their teams, right? So it is each team having their own database, managing their own deployments. I think it's what teams want. They want to move faster deployments. They want to make their new features faster to the production settings. So it's not only about fault tolerance, but also about this division of tasks between teams.
Okay, great. Thanks for the answer. And